Hi everyone, this is Vikram Sharma and we are students at the University of Windsor pursuing Masters of Applied Computing. This presentation is to explain the final project of our Advanced Computing Concepts course. The title of our project is Web Search Engine. We would like to mention our instructor and mentor for this project, Dr. Mahdi Firoozjaei. We have developed the web search engine for this project using Java on the Eclipse IDE. Here is the outline of our presentation. First, we will be discussing the roles that we assign to each other in our project. Then, we will be going through a brief introduction about our project. After that, we will be discussing the general functioning and purpose of a search engine. Then, we will show the working of our project with the help of a live demo. We will try to cover all the use cases in our project. Then, we will discuss the features and concepts that have been used in our web search engine. Finally, we will be talking about the future scope of a project and a brief overview. Here are the team members and the respective roles that we assign to each other. We individually 1, 2, 3. Here are the team members and the respective roles that we assign to each other. We individually worked on the modules as mentioned. Kalyan was responsible for working on the pattern matching and converting HTML files to text files for searching the words. Krishna worked on the spell checker and page ranking functionality, and I was responsible for developing the word prediction module for the wrong spelled words and also combining all these modules to develop a working web search engine in the Eclipse IDE. Now let's start with a brief introduction about search engines. A search engine is a software that carries out web searches. The purpose of a search engine is to search the World Wide Web to produce a relevant collection of search results that responds to the user's query. So, what exactly is a web search engine? A web search engine is a program that uses the keywords and phrases provided by the users to discover the information that the user is looking for on the World Wide Web and output the required information in the form of indexed web links. The search engine takes the input from the user in the form of phrases or keywords and examines the web page titles and contents that it has indexed. The search engine then applies the various algorithms to generate a list of the web pages that include the keywords with the most relevant ones at the top. Some of the examples of web search engines that we use daily are Google, Yahoo, Bing, etc. In the graph, we can see that Google is the most popular among the various web search engines. These web search engines. Now, I will be explaining the working of a project with the help of a live demo. We have used the Eclipse IDE to develop our web search engine. Let us take a look at the project structure first. The default package contains all the Java files responsible for running the program. The W3C Web Pages folder contains all the HTML files which get converted into text files used for searching the user input. These files are stored in the Converted Text Files folder. The dictionary text file is used to check the spelling errors in the user input. In order to make this web search engine functional, we need to first convert all the HTML files to text files. This is done using the HTML text converter Java file. Now I will run this file which will convert all the HTML files in the W3C web pages folder to text files. Here you can see the run output. The program reads the files in the W3C web pages folder and using the JSoup library converts the files to text files and stores them in the converted text files folder. Now let us see working of the web search engine file. So as you can see, the program asks for the user input. Now, there are two use cases in a project. One where the user types the word correctly spelled and the other where the user spells the word wrong. Let's first see the use case where the user spells the word wrong. As you can see, the program searches for the word in the dictionary text file and identifies the wrong spelled word. It then suggests the word which is closer to user input. Then the word is searched in the converted text files and suggestions are printed for the user. The program again prompts the user for input. Now this time when the user types the word correctly spelled, the word is searched in the converted text files folder. All the positions of the search word in the files are printed. In the end, the page ranking is printed with the page that contains the word most times at the top. Now, we will discuss the following features one by one which are responsible for the working of a web search engine. First, I will ask Kalyan to explain the HTML to text converter and pattern matching modules.
As Vikram was saying, we have a total 5 features that I have implemented, and my part is I have implemented two of those features. One is HTML to text converter, and the other one is the pattern matching. So basically, like I'll be going one by one, and due to the time constraint, I won't be explaining any features or applications that I have mentioned in the PPT. So I will explain it like what is an HTML text converter. So for a web page, as we already know that we cannot directly manipulate the HTML attributes or elements. So in order for them to be manipulated is we have to convert them first into a text. Then only we can manipulate them. So for doing that, we have some external tools called uh, JSoup. It may be a string tokenizer, or there are some other more. So what they'll be doing is they'll be parsing from top to the bottom, and they will extract all the information from the web page without the user intervention. So this is what a HTML to text converter means. Now I will explain how I have achieved in our code. For reference purpose, I have deleted these converted text files to show you how it works. So let me run this HTML to text converter. So if I run this, you can see that I took the web pages, static web pages, which are stored in W3C web pages, which is this one, and I'm sending it to parse, like convert HTML to text function, which is basically by using JSoup. I have parsed it, and I have written that into folder called converted text files. So this is a statement, output statement I have written. So if I refresh this, you can see that the text files are have been parsed successfully and has been appeared here. So the other part which I've done is the pattern matching. So as the name suggests, the pattern means regular expression and matching means matching it. So the term pattern matching means we have to match the regular expression with with the patterns or against the text. So this pattern matching, like what we'll be doing is we will be taking one pattern and we'll be converting that into a sequence of tokens, and we will check that sequence of tokens with any other with the given text, so to see that if there is any matching for that sequence of tokens, and if it is matched, then we will be returning the position. So I have implemented this in the code. Let me share that. First I'll be going to helper, and if you see here, if you this is the search word function I have written. If I go to that function, I'll be taking the file paths, and I'll be taking the user input, into a string, which is p1. So now what I'll be doing is I'll be taking a buffer reader, and I'll be taking all the files to that buffer reader, and I'll be reading all those files line by line. After that, what I'll be doing is I'll be sending that into a search function. So if I open a search function, what it will do is it will take a pattern first, and it will take the converted text, the total converted text line by line in that, and it will match this it will try to match this pattern with the text. So if the pattern matches, it will return the position of that pattern, else it will return just the length of the text. So if it is matched, it will return the position of that. If not, it will return just the length of that text. So this is how we will be implementing it. Let me demonstrate it. So if I run this, you can see enter your search. Now I will enter protocol. So if you see here, protocol is found at position 1789, and it is found in the service description w3c htm.txt. Likewise, if it is found in any other positions and in any other files, you can see that here. This is how we will implement this.
Thank you, Kalyan. Now, I will ask Krishna to explain the spell checker and page ranking modules.
So as Vikram mentioned, we've got 5 components in our project. So of those 5, I've taken up, I worked on the 2 of the components. So one of is spell checker, and the second one is page ranker. So spell checker is nothing but, so every time when we use Google, when we use any search engine, so we put up a word or a phrase when we search it up. So every time the machine checks up if the word which you put up is correct or not, and if not, it gives up a suggestion. So what? So so how the process of checking if the word or the phrase which the user has given to the machine is correct or not is only called as spell checking. So in our project, so we've used the dictionary which has been created using the inverted index process to to spell check the keyword. So what will happen is, so when a user will input a specific keyword to our search engine, so every time a user inputs a specific keyword, so it will go to the spell checker and check if the spelling is correct or not using the ask function. So using this function, the user will check up the machine will check up if the input being given by the user is a correct spelling or not. If the input given by the user is a correct spelling, then it will move forward to checking up all the website where this word has been, or the phrase which is given by the user has been used. If it is not correct, so then it will go up to word prediction. So where it will predict up the words based on it will check up the patterns and predict up the words, the nearer words. So let me say that I have given so let me take up a word as Mara umbrella. So if I give the umbrella correct word, UMBRELLA, so it will come up everything with the word umbrella. And if not, if I given let me say that instead of umbrella I give under or umber. So you see that umber. So it will the word prediction will give up the near word. So that will be explained later by my friend Vikram. So let us go into the code for this spell checker. So as we see in the web search engine.java in our project file. So whenever the usage, so I'm in the helper function. So in this function, so the string p1 is the function is the input which is provided by the user. That will be then forward. Then a spell checker will be created, and as I mentioned, so that keyword is being taken to the ask function. So let me take quickly to that function. So here you go. So here in this ask function, so what are we doing is we are first checking up if it contains. So we are using the regex pattern matching. So for that, we are compiling the pattern, and then we are matching the pattern. So when we are compiling the pattern, we just make sure that it is present, and it is the word which is given is only contains the letters A to Z in both capital and small. Then we'll use the matcher. So we are checking up with the line, and then we'll run the my dictionary function. Run the dictionary function. So here in this dictionary function, so it contains a matcher string and a string P1, which is the matcher string is nothing but the string which is as I mentioned, we are using the dictionary file. So a matcher string is nothing but the string in the dictionary, and P1 is nothing but the string which is given by the user. So here we are reading up the file. We are creating a new file reader, so which contains this file reader contains the text file of the dictionary. And we are also creating a buffer reader for that. So what does buffer reader does is nothing but it reads the dictionary file line by line. And so when the line when the so what happens is when the file is read line by line, and if the match is not null, so then it will be reset. But if there is it will be the match will be reset. So when the reset, it will be as match is 0, because there's no occurrence in the occurrence happened in the buffer in the file with the keyword given by the user. And see, when if there is a find, so this is what is happening. It is find. So then it is adding up to the group, and then it is adding up, saying that okay, fine, we've got a match in the dictionary. So then you can go up to the next part. So then the buffer rate is going. The buffer reader will be closed, and then it will go to the web search engine, where it will search up the every web pages and display it everything. So this is one of my component. And nextly we can go to the page ranking. So page ranking is nothing but as we see, you got a couple of 100 pages, and so we wanted to know whether how I would say, let us say that I would say let us think of a technical term like okay, functional array or function or a arrays, or let us say anything which is related technically. When we search up in the Google array list, so let's take an example of array list. When we search up the string as array list, so array and list are present in many of the websites. So but we need is what is nothing but as array list. So what the Google does is it ranks the pages based upon the occurrence of the word, or how much part of the array list is present in it. So that is the similar thing which is happening in down here as well. So the user types up a keyword in the search engine. So what will happen is the search engine will search the occurrence in the all web pages, occurrence of that word in the all of the web pages, and then once it will search for the occurrence, then it is being sorted based upon the page will be sorted based upon the occurrence of the keyword, so that it can be ranked up. So let me say that a keyword has a single occurrence, a keyword has a double occurrence, a keyword has a triple occurrence. So that will be based upon sorted, so that the pages can be ranked up based upon that. So I'll give you a demo for this as well. So I'll just extend up the code first. So here you go. So I'm in the same helper function. So what is happening is, so when this is nothing but here they are converting the files into the occurrence table. So they're just putting up in the occurrence table. So here you go. We are sorting up this value. So what is happening is, this is a sort value. This is happening is, so how do we rank the page? So we get up an input of the occurrence. Let just a minute. So let me get this clear for you. There you go. So when we are taking this converted file into this, and we are searching for the occurrence of each and every word as web search will do. It here it is searching for as explained by my friend Vikram. So this keyword is being searched in all the files, and as we move forward, the files are being as we move forward, the files it will go down each and every file and see of the occurrences of the first. Then once the occurrences are done, so it will So it'll print up where we've got the occurrences, and then it will go for sorting of those occurrences to the page ranking. So then I'll move to the sorting phase. There you go. So in the sorting phase, so what you're doing is you're taking a string as an we're taking the string and the occurrences as an input. We get the function variables. So string is nothing but the hash table which contains the file of occurrences, and this occurrences this int occurs is nothing but number of times the variable is being occurred. So what is happening is nothing but we're the collection. We're just creating a new collection, and we are sorting that thing. So each and every time the map entry is occurred. So let me say that each and every time occurrence has occurred. So we'll map it up. So let me say that. So we're comparing the occurrence of first occurrence and second occurrence to sort up the occurrences. So see this map has these many occurrences. So O1 here, O1 is nothing but occurrence 1 and occurrence 2. So for a specific map, this is the occurrence, and for a specific map, this is the occurrence. So what we are doing is we are using this occurrence and we are comparing it to the second occurrence. So when we see that this will comparing it to the second occurrence, and that goes on every time for every file in the for every HTML document, so that we get the number of occurrences and we can sort up the page ranking based on that. So once we get up the occurrences and we sort out the array, so then here we are just listing up the 5 top occurrences based upon the number of where the page ranking the website based upon the top number of occurrences here. So we are nothing but we are just sorting it down from the based upon the occurrences. We are just sorting it how many times. Here you go. So this prints up how many times it happens based upon the occurrences. So I'll show you a demo of that. I think my friend has already shown you how a page ranking occurs. So I'll just reiterate it again. So here you go. Okay. Let me say adapt. Adapt is a word. So I just want to know this. So adapt. See, here you go. Since adapt, I've spelled up the spelling correctly. Adapt. So it has just checked that in the dictionary, and it found a word adapt, and it directly went to searching of the web pages. And once the web pages has occurrence, so here you go. Okay, let me get this. Yeah, here you go. So here the adapt has been found. So it has found it in a couple of websites, and here you go. It has then the page ranking is nothing but it has sorted the website based upon the number of times of occurrences. So for this website device independence context, so it has occurred the adapt word has occurred 7 times. So based upon the number of occurrences of each keyword, the page ranking has been done. So so that the user can find it very easily. And now my friend Vikram will continue with this part of the presentation. Thank you.
The word prediction module of our project suggests the nearly possible words from the dictionary. It uses the dictionary which has been created using the inverted index. The program uses the concept of edit distance to find the words which have the minimum distance to the searched word and provide suggestions and predictions. Now let us discuss the future scope of a project. Development of a UI for the web search engine can complement the working of the project. More URLs can be added to the database for searching the user inputs. We can also create our own database based on the searches done by the user. Artificial intelligence can be integrated in the project for better suggestion on the queries. This course provided detailed theoretical and practical knowledge of the data structures and algorithms and the respective analysis. All these concepts helped in the development of this project. The various concepts learned during this course have been used to develop this web search engine to search any kind of queries on the World Wide Web. We learned about the working of these algorithms and developed a deep understanding of their running complexities while working on this project. So this was a presentation for the final project of Advanced Computing Concepts course. Thank you everyone for watching.